The universe hides worlds stranger than any fiction. We once thought our solar system defined what a planet could be, but the discovery of exoplanets shattered that illusion. This is a journey to 25 of the most bizarre planets ever found, a tour that will fundamentally challenge your understanding of reality itself. You will encounter a world where it rains molten glass and another that is darker than coal. What does a planet made of diamond even look like, and how can a world survive being eaten by its own star? The cosmos is filled with mysteries that defy our earthbound logic. Are you ready to see how truly alien a planet can become? Our journey begins with a world of unimaginable wealth and scorching fury. 55 Cancri is a super-Earth, a planet with about twice the diameter of our own, but any resemblance ends there. It orbits so close to its parent star that a full year, one complete trip around, takes a mere 18 hours. Imagine the sun in your sky being a gigantic, permanent fixture, so large it dominates the horizon. This proximity creates a world of extremes. Its day side, the side perpetually facing the star, is a furnace with temperatures soaring above 4,000 degrees Fahrenheit, hot enough to melt iron and vaporize rock. The surface is not one of familiar continents or oceans, but a global ocean of lava, a churning, incandescent sea under a black star-filled sky. Yet the most astonishing secret of 55 Cancri lies beneath that fiery veneer. Scientists analyzing its composition believe it is incredibly carbon-rich. Under the crushing pressures of its own immense gravity, that carbon is likely compressed into layers of graphite and, deeper down, into a crystalline lattice of pure diamond. This is not a metaphor. We are likely looking at a planet with a core of diamond, possibly thousands of miles thick, making it a literal jewel of the cosmos. It is a glittering, hellish paradox, a treasure of staggering value forged in an environment so violent that nothing, not even a robotic probe, could ever hope to retrieve it. It is a monument to the universe's capacity for creating beauty in the heart of utter devastation. That glittering diamond world offers a vision of silent, scorching wealth, but the next planet on our list trades that eerie stillness for a storm of pure, unrelenting fury. Meet HD 189,733b, a world that presents itself as a beautiful, deep blue marble from a distance, a color reminiscent of our own Earth's oceans seen from space. Do not be fooled. This azure hue is not a sign of water, but a cosmic deception. The atmosphere of this gas giant is saturated with tiny silicate particles, the same material that makes up sand and glass on Earth. These particles scatter blue light, cloaking the entire planet in a serene, inviting color that hides its true nature. The reality is a masterpiece of atmospheric terror. HD 189,733b orbits its star so closely that it is tidally locked, one side forever baking in stellar radiation, while the other languishes in eternal night. This extreme temperature difference, thousands of degrees from day to night, does not create a gentle breeze. It fuels a permanent, planet-wide hurricane. Winds scream across the atmosphere at speeds exceeding 5,000 miles per hour, over 6 times the speed of sound here on Earth. These are not winds that howl, they are winds that shatter reality itself. Now remember those silicate particles giving the planet its lovely blue tint. In the lower, hotter layers of the atmosphere, the scorching temperatures melt this silicate material. The supersonic winds then scoop up this molten glass and whip it horizontally through the skies. This is the planet's weather. It rains glass, not gentle droplets, but blistering, sideways torrents of molten silica that would scour anything to atoms in an instant. Picture standing on a hypothetical platform in that atmosphere. Not that you ever could. The sky would be a deep, beautiful blue, while around you a hurricane of liquid fire slices through the air horizontally, a beautiful, deadly illusion. It is a world where the very air is a sandblaster made of lava, proving that in the cosmos, even the most serene appearance can be a mask for a hellscape beyond comprehension. The cosmos has painted its worlds in a palette of impossible colors, from the blue glass of a hurricane to the glittering heart of a diamond. But what of a world that rejects color and light entirely? Meet TRS-2b, a gas giant so profoundly dark it holds the title of the darkest planet ever discovered. Orbiting its star at a distance of only about 3 million miles, this world reflects less than 1% of the light that falls upon it. To put that in perspective, black acrylic paint reflects about 10% of light. Charcoal reflects about 4%. TRS-2b is darker than both, an abyss in space that absorbs nearly every single photon that dares to touch its atmosphere. This is not a world of shadows, it is a shadow-given planetary form. Astronomers first detected its profound blackness by measuring the tiny, almost imperceptible dip in starlight as it passed behind its sun. The dimming was so extreme it defied all expectations. What could make a planet this black? The leading theories are as fascinating as they are eerie. Its atmosphere, superheated to over 1,800 degrees Fahrenheit by its blistering orbit, may be rich in vaporized sodium and potassium. These elements are notoriously good at absorbing visible light, but some scientists speculate that something even more exotic is at work. The intense heat and pressure could be cooking up strange, unknown chemical compounds, molecules we have never seen before that are engineered by nature to swallow light whole. Imagine you could stand on a platform near this world. You would see its star, a brilliant disk of fire in the sky, and against that brilliance, you would see the silhouette of the planet, a hole in space. But as it moved away from the star, you would expect it to brighten, to show a faint glowing edge. TRS-2b would not. It would remain a featureless, pitch-black sphere, darker than any black you have ever seen, a void that somehow has mass and gravity and presence. It is a cosmic paradox, a giant made of gas that is the visual equivalent of nothing, a reminder that the universe can create not just wonders of light, but profound and perfect darkness. If darkness can be a planet, then tragedy can be too. WASP-12b is a world living on borrowed time, a gas giant caught in a slow and spectacular death spiral. This hot Jupiter orbits its star with such intimacy that a single year passes in just over one Earth day. The gravitational embrace is so tight, so unrelenting, that it has warped the planet itself into an egg shape, stretched by the immense tidal forces of its sun. But this distortion is just the beginning of the end. The star's gravity is not just pulling on the planet's bulk, it is actively stealing its lifeblood. WASP-12b orbits so close that the star's radiation is blistering its atmosphere, superheating the gases to a point where they can no longer be held by the planet's own gravity. Every moment, a torrent of planetary material is being stripped away, siphoned off into space. This stolen atmosphere doesn't just vanish, it forms a vast swirling disk of superheated gas and dust that encircles the star, a funeral shroud being woven in real time. Astronomers can actually detect this flow, watching as the planet loses billions of tons of mass every second. This process makes WASP-12b one of the darkest and hottest planets we know, with a surface temperature soaring above 4,000 degrees Fahrenheit. Its atmosphere, ravaged and depleted, absorbs almost all light, giving it an albedo nearly as low as the pitch-black TRS-2b. But here, the darkness is not a static feature, it is a symptom of a violent unraveling. We are witnessing cosmic predation on a planetary scale. The star is not merely shining upon its companion, it is consuming it. Within another 10 million years, a mere blink in cosmic time, this entire world may be completely dismantled, its substance digested into the star's fiery core. It is a solemn reminder that in the universe, even planets are not permanent. They can be born, they can shine, and they can be eaten alive by the very hearts of their own solar systems. The darkness of a dying world gives way to another paradox, a place where fire and ice are not opposites, but locked in a single, impossible state. Gliese 436b is a Neptune-sized planet that defies every instinct we have about matter. Its surface temperature is a blistering 800 degrees Fahrenheit, hot enough to melt lead and set paper ablaze instantly. Yet this world is not a ball of lava or superheated gas. It is covered in ice, not the familiar fragile ice of Earth, but something far more alien and powerful. The planet's immense gravity, many times stronger than our own world's, creates pressures so colossal that they force water molecules into a crystalline structure known as Ice 7. This is not ice as we know it. Under that unbelievable pressure, water cannot become a liquid or a gas, no matter how much heat is applied. It is forced to remain solid, forming a scorching, compacted mineral more akin to diamond than a snowflake. This is burning ice, a shell of solid water that sizzles at temperatures which would boil oceans elsewhere. The planet's atmosphere tells another part of its tragic story. The intense radiation from its close orbiting star is relentlessly stripping away hydrogen. blowing it off into space to form a giant, glowing tail that streams behind the planet like a comet. So we are left with the complete, bewildering picture, a world of hot ice shrouded in a searing atmosphere, slowly being unraveled into a brilliant trail of stolen gas. It is a monument to the power of pressure, a reminder that the universe obeys physical laws that can create realities our earth-bound minds struggle to even picture. Here the concepts of hot and cold lose all meaning, replaced by a single, unyielding truth that under enough force, even the most fundamental rules of matter can be rewritten. Science fiction became science fact with the discovery of Kepler-16b. This is the first confirmed world ever found orbiting not one, but two stars at once, a real-life Tatooine. Picture a cold Saturn-sized gas giant locked in a graceful 41-day dance around a pair of aging stars, one orange and one red, both smaller and cooler than our sun. For decades, such a stable orbit was thought to be impossible. The gravitational tug-of-war between two stars would surely disrupt any forming planet or fling it into the void. Kepler-16b proved the universe is more clever than we imagined. It orbits at a respectful distance, finding a perfect gravitational sweet spot where the combined pull of the binary stars creates a stable path. The view from a hypothetical moon of this world would be the stuff of legend. Two suns would trace arcs across the sky, casting ever-shifting double shadows. Some days they would rise and set together, a brilliant pair. On others you might witness a double sunset, one star dipping below the horizon followed by its companion, painting the sky in layers of orange and crimson. This discovery shattered a major assumption in astronomy, proving planets can form and persist in the most complex of stellar environments. If a world can find stability here, then circumplanetary planets might be common throughout the galaxy, meaning millions of potential Tatooines are waiting in the darkness, each with a sky dominated by twin suns. The serene stability of a twin sunset world is a rare gift in the cosmos, for many planets endure orbits of pure chaos. HD 80606b is a gas giant with an elliptical path so extreme it borders on insanity. Most planets in our solar system, Earth included, follow nearly circular orbits, giving us predictable seasons and stable climates. This world follows a different rulebook entirely. Its year is 111 Earth days long, but that journey is a terrifying roller coaster. It spends most of that time drifting lazily in the outer chill, a comfortable distance from its star. Then in a matter of hours, its orbit whips it inward on a kamikaze dive, swinging closer to its sun than Mercury is 2 hours, before slingshotting back out to the frozen depths once more. This is not a gentle approach, it is a violent, close-range stellar encounter that happens like clockwork every 111 days. The consequences of this celestial daredevil act are written in its atmosphere. As the planet approaches its star, the temperature doesn't just rise, it explodes. In the span of just 6 hours, the surface temperature skyrockets from about 1,000 degrees Fahrenheit to over 2,200 degrees. That is an increase of more than 1,200 degrees in less than a single Earth afternoon. To grasp that scale, imagine a winter day so cold your breath freezes, transforming in moments into an oven hot enough to melt steel. This isn't just heating, it is a planetary-scale thermal shock. The atmosphere on the day side cannot adjust peacefully. The sudden, colossal influx of stellar radiation superheats the air, causing it to expand violently at supersonic speeds. This creates a continuous planet-wide shockwave that races ahead of the heat front, a permanent thunderclap of raw physics that circles the globe. These shockwaves, in turn, trigger hyperstorms of unimaginable ferocity. Weather systems on HD 80606b would make Jupiter's great red spot look like a gentle summer breeze. We are talking about continent-sized hurricanes born not over days, but over hours, fueled by the most extreme temperature gradient in the known galaxy, winds that could shred solid rock. This is a world of rhythmical apocalypse, a gas giant that is calmly frozen for months only to be brutally flash-fried and torn apart by its own star every season, a relentless cycle of calm and cataclysm written in the laws of orbital motion. While some worlds endure cycles of violent change, others have witnessed the entire history of the cosmos from a quiet, distant corner. PSRB 1620-26b, nicknamed Methuselah, is the oldest known planet in the entire universe. It formed roughly 12.7 billion years ago, a mere 1 billion years after the Big Bang itself. To grasp that timeline, this planet was already ancient when our own sun and Earth were nothing more than a cloud of dust in a forgotten spiral arm. Its home is as extraordinary as its age. It resides in a globular cluster, a dense spherical swarm of ancient stars orbiting the Milky Way's outskirts. Within that cluster, it performs a slow, stately dance around not one, but two stellar corpses. Its primary is a pulsar, the rapidly spinning, city-sized core of a massive star that died in a supernova. Its companion is a white dwarf, the faded, Earth-sized ember of another star. This planet orbits this binary graveyard system, a silent witness to not just one, but two stellar deaths. Its very existence is a profound cosmic puzzle. It had to form around a normal star in that violent, early cluster, then survive the apocalyptic explosion of that star as it became the pulsar. Somehow it held on through the shockwave and radiation blast that would have vaporized most worlds. Later, it had to endure the death of the second star in the system, the one that became the white dwarf. That it persists today, a grizzled survivor in a celestial boneyard, tells us something revolutionary. Planet formation was not a slow, late process in the universe's story. It began almost immediately in the most chaotic and crowded stellar neighborhoods imaginable. If planets could form and endure in such an environment, amidst the titanic explosions of the first generations of stars, then they are likely far more common and resilient than we ever dared to dream. Methuselah is more than a fossil, it is a testament. It proves that worlds have been companions to stars for nearly as long as stars have shone, and that even in the face of stellar annihilation, a planet can cling to existence, a quiet monument to 13 billion years of silence. Our galaxy holds survivors of unimaginable age, but also worlds forged in a more immediate and violent crucible. Kepler 10b is a monument to cosmic extremes, a scorched and airless sphere that stands as one of the first rocky planets ever confirmed beyond our solar system. This discovery was a landmark, proving that small, dense, Earth-like worlds could indeed exist around other stars, but any similarity to our pale blue dot ends with its rocky composition. Kepler 10b is a study in infernal simplicity. It orbits its sun-like star with such intimacy that a full year passes in less than one Earth day, a frantic 20-hour sprint through blistering radiation. This proximity locks the planet in a gravitational embrace so tight it is almost certainly tidally locked, with one hemisphere forever facing the stellar fire and the other trapped in eternal, airless night. The day side is a vision of pure hell. Surface temperatures there are estimated to soar beyond 2,500 degrees Fahrenheit, hotter than the melting point of iron. Under such relentless stellar fury, rock itself cannot remain solid. The entire sun-facing hemisphere is likely a single global ocean of molten lava, a churning, incandescent sea without a shore, perpetually stirred by the star's immense gravitational pull. There are no continents here, no mountains, no familiar geology, just a boundless, glowing expanse of liquid stone under a black, star-dusted sky. But the true nature of Kepler 10b is revealed not by its surface, but by its density. Precise measurements show it is incredibly dense, far denser than Earth. This points to a composition dominated by heavy elements, particularly iron. Scientists believe this world may have a colossal iron core, making up a staggering proportion of its entire mass. Imagine a planet where the familiar silicate rock mantle has been largely stripped away, perhaps by the star's intense heat in its early years, leaving behind a naked, super-dense metallic heart. This makes Kepler 10b not just a lava world, but an iron world. Its surface, that vast magma ocean, would be rich in molten iron and other metals, a shimmering metallic broth. The night side, shielded from the direct stellar glare, might be just cool enough for a thin, brittle crust of solidified metal and rock to form over a still molten interior, a cracked and fragile shell over a world of fire. It is a place of elemental brutality, where the very building blocks of planets are laid bare under the most extreme conditions imaginable, a reminder that the family of rocky worlds includes members shaped not for life, but for silent, scorching endurance. While Kepler 10b is a world stripped to its metallic core, other young planets are still dressed in the spectacular finery of their birth. J1407b is a colossal enigma, a young gas giant or perhaps even a failed star known as a brown dwarf, and it wears a crown of such immense scale it defies belief. This crown is a system of rings, but to call them rings is like calling the Pacific Ocean a puddle. The data reveals a ring system over 200 times larger than the majestic rings of Saturn. If you place this super Saturn in our own solar system, its rings would stretch from the Sun all the way past the orbit of Venus, utterly dominating the inner sky. The discovery was made not by seeing the planet directly, but by watching the star it orbits. Astronomers observed a bizarre, complex series of eclipses where the star's light dimmed in a wild, unpredictable pattern over several weeks. The only explanation was a vast, intricate network of rings with countless gaps and bands passing in front of the star. This wasn't a simple blink, it was a celestial light show orchestrated by a structure of almost impossible grandeur. But the rings hold an even more tantalizing secret. Within that vast disk of dust and ice, the data shows sharp, clean gaps. Around Saturn, such gaps are carved out by the gravity of small shepherd moons, which clear their orbital paths. The gaps in J1407b's rings, however, are on a different scale entirely. The mathematics suggest the objects clearing those gaps must be massive, perhaps the size of Mars or even Earth. We are likely looking at the birth cries of exomoons, giant worlds forming right now within that expansive disk. Picture the scene from the surface of one of these infant moons. The sky will be a breathtaking, impossible wall of rings, arcing from horizon to horizon in bands of dust and shadow, with the faint glow of the central gas giant hanging like a distant jewel in a cathedral of ice. It is a snapshot of a solar system in its violent, creative youth, a place where planets are not just worlds, but the architects of even more worlds, building their own families on a scale that humbles our entire neighborhood. The birth of moons within a colossal ring system speaks to a universe constantly building, but not all construction leads to warmth and light. Far from the glare of young stars in the cold, crowded heart of our galaxy, another kind of world endures in profound silence. Algol 205bg390lb is a frozen super-Earth, a discovery that redefined where we could look for planets. It was found not by watching a star wobble or dim in a regular rhythm, but through a rare and fleeting cosmic alignment called microlensing. When the planet's dim red dwarf star passed almost perfectly in front of a much more distant star, its gravity acted like a lens, magnifying the background star's light for a few weeks. A tiny, brief blip in that magnified light revealed the fingerprint of this frozen world, a technique that allows us to detect planets thousands of light years away, deep in the galactic bulge. What emerged from the data was a portrait of profound isolation. This planet orbits its faint, cool star at a distance roughly 3 times farther than Mars is from our Sun. In our solar system, that would place it within the asteroid belt, but around this feeble red dwarf, the result is a deep and permanent freeze. Surface temperatures are estimated to plunge to near negative 364 degrees Fahrenheit, only about 50 degrees above absolute zero, the point where all molecular motion stops. This is a cold so intense it defies human experience, a chill that would make the ice of Pluto feel comparatively tropical. The planet itself, with a mass about 5 times that of Earth, likely has a rocky core enveloped by a thick mantle of frozen volatiles, a global glacier of solid nitrogen, methane, and carbon monoxide. Its surface will be an airless, desolate wasteland, a cracked plain of exotic ices under a sky perpetually black, save for the faint cherry red ember of its distant sun and the dense, dusty shimmer of countless bold stars. This frozen realm is a crucial clue. Its existence in the chaotic, ancient galactic core proves that planets can form and persist in environments vastly different from our quiet suburban spiral arm, suggesting that even in the most crowded stellar metropolises, frozen, lonely worlds may be silently orbiting their dim red suns, waiting in the dark for eons. From the deep freeze of the galactic core, we swing back toward a star's blistering embrace to find a world of fire and stone. Co-Rho-T 7b is a rocky super-Earth, a place where geology itself becomes a form of weather. This planet orbits so close to its sun that a year passes in a mere 20 hours, and the gravitational forces have locked it permanently, one face forever turned toward the inferno. The day side of Co-Rho-T 7b is a single global ocean of lava with temperatures soaring above 4,000 degrees Fahrenheit. At that heat, rock does not just melt, it vaporizes. The very surface minerals, elements like sodium, potassium, and silicon monoxide, are boiled directly into a thin metallic vapor that forms a tenuous, scorching atmosphere. This is not an atmosphere of nitrogen and oxygen, but a sky of vaporized stone. Now follow that vapor as it rises from the lava seas. Prevailing winds, driven by the extreme temperature difference, would carry this mineral fog toward the planet's eternal night side. As the gas crosses the terminator line into darkness, the temperature plummets by thousands of degrees in just a few miles. In that sudden, profound cold, the rock vapor cannot remain a gas. It condenses. It would first form tiny droplets of liquid rock, which would then solidify into fine grains and pebbles, and then on the dark, frozen hemisphere of this hell world, it would snow. Not snow of water ice, but snow of rock. Imagine standing on that frigid, barren landscape. The ground beneath your feet would be a brittle crust of solidified lava. Above, in a sky devoid of a sun, you might see faint, glowing clouds of silicate vapor creeping over the horizon from the dayside, lit by the distant lava ocean's glow. From those clouds, a gentle, gritty rain would begin to fall, a shower of tiny stone hailstones accumulating into drifts of gravel and sand. This is the planet's water cycle, reimagined in stone. The dayside boils rock into a gas, the winds carry it aloft, and the nightside freezes it back into solid form. It is a world with a lithosphere, an atmosphere, and a precipitation cycle, all made from the same material, a terrifyingly elegant and closed loop of geological fury. Any traditional atmosphere it once had has long since been boiled away and stripped by the star, leaving behind this minimalist, brutalist exchange of vaporized and condensed rock. Co-Rho T7b presents a stark vision of a planet reduced to its most elemental processes, where the very ground you stand on is perpetually being evaporated from one side and snowed back onto the other. The brutal geology of Co-Rho T7b offers a stark contrast to the most hopeful discovery in the exoplanet catalog. Kepler 22b is a world of profound possibility, the very first planet ever confirmed to orbit comfortably within the habitable zone of a sun-like star. This discovery, announced in 2011, was a watershed moment, transforming the search for alien life from pure speculation into a tangible, data-driven pursuit. Here was a world, a super-Earth about 2.4 times the size of our own, circling a star very similar to the Sun in a 290-day orbit. That orbital distance is the magic number. It places Kepler 22b in the region around its star where temperatures are just right, where a planet with a suitable atmosphere could maintain liquid water on its surface. Not too hot, not too cold, but potentially just right for the chemistry of life as we understand it. While we do not yet know its composition, the most tantalizing models suggest it could be what scientists call an ocean world, a planet with little to no land, its entire surface shrouded beneath a deep, global sea. Imagine a world with no continents, no mountains breaking the waves, just an endless planet-wide ocean under a hazy, alien sky. The view from orbit would be a serene, unbroken blue marble, perhaps streaked with white clouds, a single water droplet suspended in the void. The significance of Kepler 22b cannot be overstated. Before its confirmation, the habitable zone was a theoretical line on a graph. This planet gave it a name, an address, and a face. It proved that stars like our Sun could host worlds in that Goldilocks sweet spot, that the basic architectural blueprint for an Earth-like environment exists elsewhere in the galaxy. It told us that the fundamental ingredients for life, a stable star, an orbit that allows for liquid water, and presumably the same cosmic abundance of elements found everywhere, could come together in one place 600 light years away. This world is not a confirmed paradise, and it may be utterly inhospitable beneath its clouds, but it stands as a beacon. It represents the moment we looked up and for the first time could point to a specific point of light and say with scientific confidence that there is a world there where nature might have taken the same path it did here, a silent answer to humanity's oldest and most profound question: are we alone? The hope of a distant ocean world finds a more immediate and far stranger candidate much closer to home. GJ1214b is a super-Earth, a world about 2.7 times the size of our own, orbiting a dim red dwarf star just 40 light years away. What sets this world apart is not its orbit or its star, but its profound and alien composition. Detailed measurements of its mass and radius reveal a startling truth: this planet is far too light for its size to be made of rock and metal like Earth. Instead, the numbers point to a globe made overwhelmingly of water, enveloped by a thick, dense atmosphere. GJ1214b is not a world with oceans, it is an ocean that has become a world. Its atmosphere is a perpetual global fog, a deep shroud of steam and hydrogen hundreds of miles thick, blocking any view of the surface below and trapping immense heat. But the true mystery lies beneath that eternal mist. Scientists believe the surface pressure on this world would be hundreds of times greater than the crushing depths of our deepest ocean trenches. Under such incredible pressure, water behaves in ways that seem like magic. The familiar states of liquid, solid, and gas blur into exotic, high-pressure forms of matter we can only create in laboratories. Descending through the steamy atmosphere, you would not find a sharp shoreline or a rocky coast. You would encounter a global ocean with no bottom, at least not one made of stone. The immense pressure would force the water into a bizarre substance known as supercritical fluid, a state where liquid and gas become indistinguishable, a searing, dense, soupy medium. Deeper still, the pressure might compress the water molecules into various crystalline structures, forming layers of exotic ices like Ice 6 or Ice 7, not cold at all, but heated to hundreds of degrees. This is hot ice, a solid that exists only because the weight of the entire ocean above is so immense it crushes the water into a lattice despite the fierce temperature. The very core of this world might be a small, rocky sphere, but it will be buried under hundreds, perhaps thousands of miles of these alien aquatic layers. GJ1214b represents an entirely new class of planet, one our solar system lacks, a water world with no true solid surface. There is no land here, no continent to provide refuge, just an endless pressurized abyss where the very idea of a shore is a fantasy. It is a haunting and beautiful vision, a planet that is less a place and more a single colossal droplet, a reminder that the most common compound in the universe can, under the right conditions, become the architect of a world unto itself. Such profound strangeness in a world's very substance is matched only by the bizarre mechanics of its motion. WASP-17b is a gas giant that defies all sense of direction. Every planet in our solar system, and indeed the vast majority we have discovered, orbits its star in the same direction that the star itself spins, like marbles rolling along the rim of a spinning plate. It is a fundamental signature of the orderly disk of gas and dust from which solar systems are born. WASP-17b does the opposite, it moves backwards. This is a retrograde orbit, a celestial rebel that circles its star in a direction completely contrary to the star's own rotation. Discovering this was like watching a clock's hand spin counterclockwise, a violation of a seemingly universal rule. This single fact sends shockwaves through our understanding of planetary birth. A planet cannot form naturally in such a backward spinning orbit from the original stellar nursery disk. Its existence is a glaring signpost pointing to a violent past. The most likely explanation is a gravitational disaster of epic proportions early in this system's history. Perhaps WASP-17b was born in a normal prograde orbit much farther out, but a close encounter with another massive planet, a gravitational slingshot, sent it careening inward on a wild, tilted path. Over eons, interactions with the star and the remnants of the disk could have circularized its orbit, but locked it into this permanent backward march. It is a fossil record of chaos, a world that bears the scars of a gravitational battlefield we can only reconstruct through mathematics, but its rebellion does not end with its orbit. WASP-17b is also a study in astonishing lightness. Despite being nearly twice the diameter of Jupiter, it has only about half of Jupiter's mass. This gives it an almost impossibly low density, less than that of styrofoam. It is a cosmic puffball, a gas giant so inflated that if you could find an ocean large enough, it would float. This extreme puffiness is another gift of its torturous history. The planet's wildly eccentric initial orbit would have brought it scorchingly close to its star during each pass, baking its atmosphere with intense tidal heating. This constant rhythmic flexing pumped energy into its gaseous layers, causing them to expand and bloat to their current, ethereal state, so we are left with the complete portrait of a planetary anarchist. A world that moves backwards against the flow of its entire system, a world so light and distended it seems more like a stellar cloud than a planet. its very form a testament to a youth of gravitational violence and stellar fury. It is a permanent celestial counterpoint, a reminder that not all worlds find peace in their orbits, and that some carry the marks of their turbulent origins for all time. The universe's rebels and water worlds challenge our expectations, but one discovery offered a glimpse of something hauntingly familiar. Kepler 186f stands as a quiet milestone, the first planet we ever found that is nearly Earth-size and orbits comfortably within the habitable zone of its star. This was not another bloated gas giant or a scorched cinder, but a world with a radius only 10% larger than our own, a place where gravity and landscape might feel almost recognizable. Its home is a system of 5 planets circling a small, cool red dwarf star about 500 light-years away. Kepler 186f is the outermost member of this family, completing a leisurely 130-day orbit in what we call the conservative habitable zone, the region where liquid water could exist given the right atmospheric conditions. Its dim crimson sun provides only about a third of the stellar energy our planet receives, casting a perpetual twilight glow. If this world is rocky, as scientists strongly suspect, its surface will be bathed in an eternal sunset hue. Imagine standing on a hypothetical continent there. The sky would not be blue but a dim reddish-orange even at midday. The sun itself would appear about a third larger in the sky than our own, but its light would be faint and ruddy, more like the embers of a dying fire than the brilliant yellow-white we know. Photosynthesis, if it evolved, would have to adapt to this crimson light, potentially painting any plant life in deep shades of black or purple to absorb every precious photon. The climate would be a delicate balancing act, heavily dependent on the composition of its atmosphere. A thick, insulating blanket of greenhouse gases like carbon dioxide would be crucial to trap the star's meager heat and keep water liquid. Without it, the world would be an icy snowball. With too much, it could become a sweltering, Venus-like oven. Kepler 186f represents a profound step in our search. It moved the goalposts from asking if Earth-sized worlds could exist in the habitable zone to asking what those worlds are actually like. It is a testament to the quiet, numerous red dwarf stars that fill our galaxy, suggesting that small, rocky planets in temperate orbits may be far more common than the giant, blazing worlds we found first. This distant, ruddy dot is a mirror held up at a faint and strange angle, showing us a version of home under an alien sun. The serene possibility of a twilight Earth gives way to a world where the sky itself is a treasure chest of impossible jewels. P7b is an ultra-hot Jupiter, a gas giant so close to its star that its day side simmers at over 4,000 degrees Fahrenheit. But its true marvel is not just the heat, but what that heat might be crafting in its upper atmosphere. On Earth, clouds are made of water vapor or ice crystals. On this distant world, the clouds could be made of corundum, the very mineral that, when tinted with traces of other elements, forms rubies and sapphires. The atmospheric chemistry on its permanent day side is so extreme that aluminum and oxygen atoms could bond into this crystalline structure, condensing directly out of the scorching air to form vast, glittering cloud decks. Picture the view from within that searing sky. Instead of white, fluffy vapor, the heavens will be streaked with deep crimson and vibrant azure, the colors of gemstones suspended in a perpetual, scorching haze. These would not be gentle, drifting formations. The planet is tidally locked, with one side an eternal day and the other an endless night. This creates a tempest of unimaginable force as the blistering heat on the day side drives supersonic winds that race to redistribute energy to the frozen night side. These winds, screaming at thousands of miles per hour, would whip the corundum clouds around the planet in a furious, glittering tempest. Storms the size of worlds could form, their cores shimmering with the latent fire of rubies, their edges sheen with the cold blue of sapphires, all churning in a violent, beautiful ballet. It is a world of horrific violence and breathtaking beauty fused into one, a planet where the sky rains precious stones in a hurricane of fire, proving that the universe's artistry often appears in the most inhospitable of forges. Gemstone clouds offer a vision of beauty forged in fire, but Kelt 9b exists in a realm where fire itself is redefined. This is the hottest planet ever discovered, a gas giant orbiting a blue type of star that burns twice as hot as our sun. Its orbit is a study in celestial audacity, a year that passes in just 36 hours, bringing it so close to its stellar host that its day side is not merely heated, but incinerated. Temperatures there soar beyond 7,800 degrees Fahrenheit. That is hotter than the surface of many red dwarf stars. At this level of thermal violence, the basic rules of chemistry break down. On Earth, molecules like water and carbon dioxide are stable building blocks. On the day side of Kelt 9b, these compounds cannot exist. The intense ultraviolet radiation from the blue star smashes them apart, dissociating them into their raw atomic components. Hydrogen, oxygen, and carbon are stripped of their bonds and sent swirling in a chaotic elemental soup. This creates a bizarre and lopsided world. The permanent day side is an atomic furnace, a hemisphere scoured clean of all molecular complexity. Yet the planet spins, and as its atmosphere rotates into the eternal night side, temperatures drop dramatically, though still to a searing several thousand degrees. In this relative cool, the atoms racing from the day side might find a fleeting moment of respite. They can crash into one another and for a short time reform into those familiar molecules like water or titanium oxide, only to be torn apart once more as they spin back into the stellar inferno. This planet lives in a perpetual cycle of creation and destruction at the molecular level, but its most dramatic feature is its own dissolution. Like WASP 12b, Kelt 9b is being evaporated. The extreme heat is puffing up its atmosphere, causing it to expand like a balloon held over a flame. The star's gravity then strips this bloated, superheated gas away, pulling it into a vast, glowing tail that streams behind the planet as it orbits. Astronomers have detected this evaporative wind, a comet-like plume of stolen planetary material. Each orbit strips away millions of tons of mass. Kelt 9b is not just a planet, it is a slowly disintegrating monument to stellar fury, a giant being vaporized before our eyes, teaching us the ultimate limit of how close a world can dare to orbit its star. That relentless stellar fury makes the quiet, steady glow of another star feel like a sanctuary. Kepler 452b is a world that feels like home, not in its details, but in its profound, haunting familiarity. Discovered in 2015, it was immediately hailed as Earth's older, bigger cousin, the closest match we had ever found at the time. This planet orbits a star almost identical to our Sun, a G2-type star, but one that is 6 billion years old, 1.5 billion years more senior than our own. This single fact imbues the entire system with a sense of deep cosmic maturity. Imagine a star that has shone with stable, yellow-white light for 60% longer than our Sun has even existed. Kepler 452b circles this ancient sun in 385 days, an orbital year just 20 days longer than our own, and it sits squarely in the center of its star's habitable zone. The planet itself is about 60% larger than Earth in diameter, placing it in the category of a super-Earth. While we cannot yet be certain of its composition, its size makes a rocky world with a substantial atmosphere a strong possibility. The sheer age of the system is its most compelling feature. Our Sun took hundreds of millions of years for Earth to cool, for oceans to form, and for the first faint whispers of life to emerge in its depths. Kepler 452b has had 6 billion years for such processes to unfold. If it is a rocky world with plate tectonics and oceans, its geology would be ancient and settled, its continents worn smooth by eons of erosion, its climate long stabilized. The potential for life to have not only begun but to have evolved into complex, perhaps even intelligent forms, is a staggering thought. This is not a young, volatile firebrand of a world. It is a potential elder statesman of the galaxy. Looking at Kepler 452b is like looking at a possible future for our own planet, or a glimpse of what another Earth might have become with an extra 1.5 billion years of history. It represents the ultimate goal of the planetary hunt, a world that ticks so many of the boxes for habitability around a star so like our own. It is not Earth 2.0, but it is the most convincing sketch of one we have ever drawn, a reminder that the ingredients for a familiar story of oceans, continents, and skies may have been mixing under an alien sun for longer than our planet has been alive. Kepler 452b's ancient stable promise shows one path a world can take, but the cosmos has far more brutal histories written in planetary wreckage. Tewa 849b is a fossil of a different kind, a planetary crime scene that defies simple classification. Discovered by the test satellite, this world is roughly the size of Neptune, but any similarity ends there. Neptune is a gas giant, a fluffy ball of hydrogen and helium with a relatively small, dense core at its heart. TOI 849b is the opposite. It possesses almost the exact same dimensions as Neptune, yet its mass is over twice as great. This gives it an astonishing, unprecedented density. This is not a gas giant. It is a solid, rocky or metallic sphere with barely any atmosphere to speak of, a naked core floating in space. The conclusion is as shocking as it is simple. This world was once a gas giant like Jupiter or Neptune, a majestic king of its system crowned with vast, swirling layers of gas. Something catastrophic stripped all of that away, billions of tons of atmosphere violently removed, leaving behind only the dense planetary heart. It is the skeleton of a giant, the exposed engine room of a world that once was. How does a planet lose its entire gaseous envelope? Astronomers are staring at this cosmic puzzle with two leading, terrifying theories. The first is a story of slow, stellar predation. Perhaps TOI 849b once orbited farther out, but gravitational interaction sent it spiraling inward, past the safety of the so-called hot Jupiter zone and into an extreme, scorching embrace with its star. The stellar radiation and heat, far more intense than what evaporates worlds like WASP-12b, could have simply boiled and blasted away the entire gaseous shroud over millions of years, leaving the heavy core behind like a fruit peeled down to its pit. The second theory is far more violent, a single apocalyptic event. Imagine a direct head-on collision with another massive planet early in the system's chaotic youth. The titanic impact would not just shake the world, it would have been a glancing blow that ripped through the gaseous layers with the force of 1 billion nuclear bombs, literally blowing the atmosphere clean off into space in one catastrophic event, a planetary decapitation. Both scenarios paint a picture of unbelievable violence. Studying this bizarre object is like being handed the geological core of the Earth, but for a gas giant. It gives us a direct, unmediated look at the building blocks of these colossal worlds, the heavy elements of rock and metal that first seeded their formation. What is it made of? Is it mostly iron, like a supersized version of mercury, or a mix of silicates and other dense minerals? Its very existence rewrites the rulebook, proving that planets can end up in states we never predicted, and that the border between a gas giant and a super-Earth is not a fixed line, but a spectrum of tragedy and survival. Just 4.2 light-years away, a world orbits the very star next door. Proxima Centauri b is not just another exoplanet, it is our closest known planetary neighbor, a rocky promise right in our own cosmic backyard. This super-Earth, with a mass at least 1.3 times that of our own planet, circles a small, faint red dwarf star called Proxima Centauri, the third and dimmest member of the Alpha Centauri star system. Its orbit is a tight 37-day sprint, but because its star is so cool and faint, that proximity places it squarely within the habitable zone. There is a chance, however slim, that temperatures there could allow for liquid water to pool on its surface. The view from this world would be utterly alien. Its sun would appear large and dim in a perpetual reddish-orange sky, casting a twilight glow across a potentially rocky landscape. A year would pass in little over a month, and the planet is likely tidally locked, meaning one side basks in eternal ruddy daylight, while the other is frozen in endless night. This presents a profound challenge for habitability, as any atmosphere and oceans would need to efficiently redistribute heat around the globe to prevent one side from boiling and the other from freezing solid. But the greatest threat comes from the star itself. Red dwarfs like Proxima Centauri are notoriously tempestuous in their youth. They frequently erupt with massive stellar flares, sudden explosions of radiation and charged particles that can be hundreds of times more powerful than anything our sun produces. A planet like Proxima b, orbiting so close, would be utterly exposed. Such a flare would bathe the entire world in a torrent of X-rays and ultraviolet light, potentially stripping away any atmosphere over time and scouring the surface of any nascent life. It is a world of stark contrasts, a potentially temperate orbit shadowed by the constant threat of stellar violence, yet its incredible proximity makes it the prime target for humanity's next great leap. This is the first exoplanet we might one day see directly, not as a data point, but as a pixelated dot in a telescope. Concepts for future giant space telescopes are already designed with Proxima b in mind, hoping to analyze the chemistry of its atmosphere from across the interstellar void. And while it remains a dream for now, its location has ignited serious discussion about interstellar probes. Projects like Breakthrough Starshot envision sending tiny, laser-propelled sails on a flyby mission within a human lifetime. Proxima Centauri b transforms the fantasy of other worlds from a distant abstraction into a tangible destination. It is the closest answer to the question of whether we are alone, a silent neighbor waiting in the dim red light, challenging us to look, to reach, and to finally cross the vast gulf between the stars. Proxima b's red dwarf dangers highlight a harsh truth, but a different kind of world offers a gentler, if utterly alien, hope. K218b is a super-Earth orbiting a cool red dwarf star about 110 light-years away. For years it was simply another intriguing world, but recent observations have transformed it into something revolutionary. The data paints a picture unlike any in our solar system, a world classified as a Hycean planet. This new term combines hydrogen and ocean, and it describes a potential new class of habitable environments. K218b is about 8.6 times the mass of Earth, placing it in a size category between our rocky home and the ice giants like Neptune. Its atmosphere, however, is the key. Spectroscopic analysis from telescopes like Hubble revealed the clear signature of water vapor in its hydrogen-rich air. This is not a trace amount, but a significant presence, suggesting a thick, steamy atmosphere enveloping the entire globe. Beneath that immense atmospheric shroud, scientists believe the conditions of pressure and temperature could allow for a truly staggering feature, a global liquid water ocean. This would not be an ocean like Earth's, resting on a rocky crust. The pressures at the base of this ocean would be hundreds of times greater than our deepest trenches, creating a barrier so intense it might prevent the water from ever contacting a solid seafloor. Instead, the ocean could transition directly into a layer of high-pressure ice or supercritical fluid above a rocky metallic core. The surface of this ocean will be unimaginably hot by our standards, perhaps hundreds of degrees Fahrenheit, but the crushing pressure from the thick hydrogen atmosphere above keeps the water from boiling away. It is a global perpetual pressure cooker. The concept of a Hycean world like this radically expands the search for life. We have long focused on Earth twins, planets with nitrogen, oxygen atmospheres, and familiar shorelines. But life is tenacious, and microbial ecosystems on Earth thrive in extreme places, from deep-sea hydrothermal vents to acidic hot springs. A Hycean planet's ocean, though scalding, could be rich in dissolved nutrients from a rocky core below, and the hydrogen-rich atmosphere could drive exotic but stable chemistries. The detection of water vapor on K218b is a landmark, the first time we have identified water in the atmosphere of a planet in its star's habitable zone that is not a gas giant. It tells us that the ingredients for a vast, enduring ocean exist under alien suns. While we do not yet know if this specific world harbors life, it opens a door to an entirely new realm of possibility, where the most common element in the universe, hydrogen, and the most vital solvent for life, water, combine to create environments that, while utterly hostile to us, might be perfect cradles for biology we have yet to dream of. Red dwarf stars may be tempestuous, but they can also be prolific architects of worlds. Orbiting a star just 40 light-years away is a solar system that redefines the meaning of a crowded neighborhood. The star is TRAPPIST-1, an ultra-cool red dwarf so faint and small it is only slightly larger than the planet Jupiter, glowing with a dim cherry red light. Around this tiny ember whirls a family of 7 rocky planets, each one remarkably close in size and mass to Earth. This is not a system with 1 or 2 interesting worlds. It is a complete, compact laboratory of terrestrial planets. Their orbits are incredibly tight. All 7 would fit comfortably inside the distance between our Sun and Mercury. A year on the innermost world passes in just 1.5 Earth days, while the outermost takes about 20. If you stood on the surface of one of these worlds, the view would be nothing short of breathtaking. The parent star would appear about 3 times larger in the sky than our Sun, but its light would be a dim salmon pink glow, casting long, deep shadows. And in that sky you would see your sibling planets. They would not appear as mere points of light, but as distinct, magnificent disks, some appearing larger than our moon, hanging in the perpetual twilight like celestial marbles. You could watch their phases change as they orbit, and even witness transits as one world passes in front of another, a celestial dance performed on a stage smaller than our own inner solar system. The most tantalizing fact is that 3 of these 7 siblings, planets E, F, and G, orbit squarely within the star's habitable zone. This means that theoretically, all three could have the right temperatures for liquid water to exist on their surfaces. The opportunity here is unprecedented. For the first time, we are not looking at a single, possibly habitable world in isolation. We are looking at three potentially temperate planets in the same system, all formed from the same primordial material around the same star. This allows for a science called comparative planetology. We can ask, why is one world a dry desert, another a global ocean, and another a frozen snowball? What subtle differences in distance, composition, or atmospheric history led to such divergent fates? The dynamics of this compact system also raise fascinating questions. The planets are so close together that their gravitational pulls significantly affect each other, creating rhythmic orbital resonances. As they orbit, they tug on one another in a precise mathematical harmony that keeps their path stable. This constant gravitational flexing likely generates internal heat through tidal forces, much like Jupiter's moons, which could drive geologic activity such as volcanism, potentially recycling nutrients and supporting subsurface oceans, even on worlds outside the traditional habitable zone. The possibility of tidal locking, where one face permanently faces the star, adds another layer of complexity. A thick atmosphere could distribute heat around the globe, preventing the day side from scorching and the night side from freezing solid. The TRAPPIST-1 system is a gift to science, a complete set of Earth-sized experiments orbiting a single, nearby star. It offers our best chance to not just find one world that might harbor life, but to understand the entire spectrum of possibilities for small, rocky planets, and to finally answer why, in a family of 7, only some worlds become living gardens while others remain silent stones. While the TRAPPIST system dazzles with its crowded family, another nearby star holds a quieter, perhaps even more promising secret. Just 12 light-years away, a faint red dwarf named Teegarden star hosts two of the most Earth-like worlds we have ever found. This ancient star is a cosmic senior citizen, over 8 billion years old, and its calm, steady nature is its greatest gift. Unlike the flare-prone red dwarfs that threaten Proxima b, Teegarden star is remarkably placid, offering its planets a stable, gentle light. Orbiting this stellar ember are two rocky planets, each with a mass incredibly close to our own Earth. Teegarden star B and C are not super-Earths. They are near-Earth twins in terms of size and weight, a rarity in our catalog. Their orbits are measured in Earth days, with planet B completing a year in just under 5 days and planet C in about 11. Crucially, both of these worlds orbit within their star's habitable zone, that temperate band where liquid water could exist. The calculations for Teegarden B are particularly stunning. When scientists run the numbers on its mass, radius, and estimated surface temperature, it achieves one of the highest Earth Similarity Index scores ever recorded. This index is a mathematical measure of how closely a world mirrors our own in key characteristics, and Teegarden B ranks among the very top contenders. The view from either planet would be one of profound tranquility. Their small, dim sun would hang in a perpetual twilight sky, casting a deep red glow across potentially rocky landscapes. Because they orbit so close to their quiet star, they are likely tidally locked, with one face in eternal day and the other in endless night. Yet the immense age of this system works in its favor. Over 8 billion years, these worlds have had ample time for their climates to stabilize. A thick atmosphere could have formed, efficiently circulating heat from the bright side to the dark, potentially creating a wide, temperate band along the twilight line where conditions are just right. This combination of factors, Earth-like mass, a stable orbit in the habitable zone, and an ancient, quiet star, makes the Teegarden star system a crown jewel in the search for life. It represents a target where the cosmic noise is low and the signal of potential biology might one day be clear. If life ever took root here, it has had billions of years, more than on Earth, to evolve and flourish under that constant ruby sun. Yet for all the worlds we have found orbiting distant suns, the most tantalizing mystery might still be hiding right here in our own solar system. We have journeyed past Neptune and into the dark, frozen realm of the Kuiper Belt, a vast disk of icy debris left over from the solar system's formation. Here, astronomers have noticed something profoundly strange. Several of the most distant known objects in this belt, small icy worlds like Sedna, share a peculiar orbital signature. Their elongated paths around the sun are mysteriously clustered, as if an unseen hand is herding them, keeping them from scattering into the void. The mathematics of gravity points to only one plausible explanation: a massive, undiscovered planet. This hypothetical world is known simply as Planet 9. The evidence suggests it is no small rock. To exert such a distant gravitational influence, it would likely be a super-Earth or a mini-Neptune, with a mass up to 10 times that of our own world. Its orbit, however, would be unlike anything else in our neighborhood, a monstrously elongated ellipse that takes it on a lonely 15,000 to 20,000 year journey around the Sun. At its closest approach, it might swing within a few hundred times Earth's distance from the Sun, still far beyond Neptune. At its most distant, it would vanish into the profound blackness, over 20 times farther out than that. Finding it is the ultimate cosmic detective story. Telescopes around the world are engaged in a meticulous, pixel-by-pixel search of the predicted swath of sky where it could be lurking. The challenge is immense. At such distances, even a giant planet would reflect only the faintest whisper of sunlight, a single, slow-moving dot of light against a backdrop of millions of stars. Its motion would be almost imperceptible from night to night. Confirming Planet 9 would be a discovery that rewrites the story of our own cosmic home. How did such a large world end up in such a bizarre orbit? Was it flung outward by a gravitational dance with Jupiter or Saturn in the solar system's violent youth? Or is it a rogue planet, captured from another star that passed by long ago? Its existence would solve one great mystery of orbital mechanics, but instantly create so many more about our own origins. This hunt brings our tour of 25 strange worlds to a fitting close, not with a definitive answer, but with a profound question mark hanging over our own doorstep. It reminds us that discovery is not just about looking outward to the galaxy's farthest reaches, but also about peering into the deep, familiar shadows of our own celestial backyard, where the greatest secrets may still be waiting, silent and unseen, for the light of our curiosity to finally find them. This breathtaking tour across 25 alien worlds reveals a universe far more creative and bizarre than our ancestors ever dared to dream. We have witnessed scorching diamonds, sideways glass storms, and pitch-black giants darker than charcoal. We have met worlds of burning ice, planets being eaten alive, and ancient survivors from the dawn of time. Each discovery, from the serene promise of ocean worlds to the gravitational ghost of Planet 9 in our own backyard, chips away at our Earth-centric assumptions. These are not mere curiosities, they are fundamental data points in a grand cosmic experiment. They tell us that planet formation is not a neat, orderly process, but a chaotic, violent, and infinitely variable art. Gas giants can be stripped to their naked cores, water can become a planetary foundation, and stability can be found orbiting twin suns or in the graves of dead stars. This staggering diversity forces us to expand our definition of what a planet can be, and in doing so, it radically widens the possibilities for where life might take root. The chemistry that sparked biology on Earth is built from common cosmic ingredients, and we now see those ingredients combined in endless new recipes across the galaxy. So as we look up at the night sky, we are no longer just looking at points of light. We are looking at potential lava oceans, ruby cloud decks, and global seas under alien suns. The search has just begun. Which of these strange worlds captured your imagination the most? Was it the diamond planet, the world of gemstone clouds, or the silent, ancient survivor, Methuselah? Let us know in the comments below. If you enjoyed this journey to the edges of cosmic possibility, subscribe and join us as we continue to explore the deepest mysteries the universe has